If this was a volcano in places where people lived, they would be evacuated. That's not a line from a disaster movie. That is a direct quote from a leading scientist, Professor William Wilcock at the University of Washington, and he's talking about a very real threat that is brewing right now, hidden from our sight. Deep beneath the waves of the Pacific Ocean, a colossal underwater volcano is stirring. It's been rocked by hundreds of earthquakes every single day, and the pressure is building towards a catastrophic release. This is the story of Axial Seamount, the most active volcano in the Pacific Northwest, and it may be about to put on a show of primordial power that will dwarf anything we've seen from it in a decade. So what exactly is happening 300 miles off the coast of the United States? Why are scientists on such high alert, and what could this deep-sea Titan's awakening mean for millions of people living just a few hundred miles away? In this investigation, we are diving nearly a mile beneath the ocean's surface to understand the forces at play. We will uncover why experts believe an eruption could happen any day now, explore the mind-boggling scale of its last major eruption, and reveal the chilling connection between this underwater behemoth and one of America's most dangerous land-based volcanoes, which looms over cities like Seattle and Portland. The clock is ticking, and the deep is sending us a warning. Imagine a giant, sleeping beast, its breath slow and steady. For years, that's been the state of Axial Seamount. But now, the beast is stirring, its breathing becoming ragged and shallow. Scientists, our sentinels in the deep, are listening to these tremors with growing concern. Using an incredible array of ultra-sensitive sensors, from underwater seismometers that detect the faintest shiver to advanced GPS stations that measure the swelling of the seafloor itself, they have confirmed that something profound is changing. This isn't just a few sensors dropped overboard. This is one of the most advanced scientific instruments on the planet, known as the Cabled Array, part of the Ocean Observatories Initiative. Imagine a permanent, high-tech city on the seafloor. A network of high-speed fiber optic cables stretches for hundreds of miles across the seabed, directly connecting these instruments to shore. This gives scientists an unprecedented, real-time, 24/7 view into the volcano's heart. They have high-definition cameras streaming live video from the abyss, chemical sensors sniffing the water for volcanic gases, and tilt meters measuring the seafloor's angle to a fraction of a degree. Maintaining this underwater observatory is a Herculean task, battling immense pressure, corrosive saltwater, and the occasional curious deep-sea creature. But the payoff is immense, a continuous, high-fidelity stream of data that is our best and only early warning system for what's brewing below. The volcano is now being shaken by around 100 earthquakes every single day. On some days, that number has recently spiked to a staggering 300. Now, these quakes are small, typically a magnitude 1 or 2 on the Richter scale. They are far too deep and distant for anyone on the coast to feel. But it's not their power that's alarming, it's their relentless frequency. Each tiny tremor is a message from the depths. It's the sound of superheated magma, molten rock from the Earth's mantle, forcing its way upwards through a complex network of cracks and fissures in the planet's crust. Think of it like a vast underground plumbing system that's starting to overload. At the heart of this system, half a mile beneath the seafloor, lies the volcano's magma chamber, a massive reservoir of molten rock. As fresh magma from deep within the Earth pushes into this chamber, it inflates like a colossal balloon, stressing the surrounding rock to its breaking point. But this volcanic activity doesn't just spell potential doom. Paradoxically, it is also a source of incredible life. Dotted across the volcano's surface are hydrothermal vents, often called black smokers. These are surreal, chimney-like structures spewing superheated, mineral-rich water from the Earth's interior. In the crushing darkness and near-freezing temperatures of the deep ocean, where sunlight can never reach, these vents create oases of life. Instead of photosynthesis, life here is powered by chemosynthesis. Strange, alien-like tube worms, some several feet long, with blood-red plumes, thrive in this toxic brew. Ghostly white crabs scuttle across the seafloor, and vast mats of microbes form the base of a food chain that is completely independent of the world above. It is a world born from the volcano's inner fire, a vibrant community living on the edge of a loaded gun, a stark reminder that creation and destruction are two sides of the same powerful coin. Every crack, every groan, every shudder is another earthquake, another sign that the pressure is reaching a critical threshold. And if the past is any guide, this is just the opening act for a truly spectacular event, as during the next eruption, the number of quakes is expected to skyrocket to as many as 10,000 within a single 24-hour period. To truly grasp what's at stake, we need to turn the clock back to the year 2015. That was the last time Axial Seamount truly awoke from its slumber, and it did so in spectacular fashion. The warning signs then were even clearer than they are now. The daily earthquake count began to climb relentlessly. First, it hit 500 quakes per day. Then it surged to 1,000. In the final frantic hours before the eruption, the volcano was shuddering with an unbelievable 2,000 earthquakes a day. When the breaking point was finally reached, the eruption was a display of raw geological power. Lava didn't just seep out, it poured from fissures on the seafloor, creating vast lava flows that were an astonishing 450 feet thick. Imagine a river of molten rock the height of a 45-story skyscraper spreading across the bottom of the ocean. As this intensely hot lava met the near-freezing seawater, it instantly formed bizarre, bulbous structures known as pillow lavas, huge tube-like formations of solidified rock that look like something from another world. But the event wasn't just about adding new rock to the seafloor. It was about reshaping the very crust of the Earth. The eruption triggered an incredible 8,000 earthquakes in total, and as the magma chamber violently emptied itself, the immense pressure that had been holding up the seafloor vanished. The result? The entire caldera, the massive crater at the volcano's summit, collapsed, sinking by nearly 8 feet in a matter of hours. The bottom of the ocean literally fell. When scientists sent remotely operated vehicles, or ROVs, down to survey the aftermath, they were met with a transformed landscape. The seafloor was covered in vast fields of fresh, black, glassy basalt. The new pillow lavas were still warm to the touch of the ROV's instruments. Entire vent fields that had been teeming with life just weeks before were now buried under hundreds of feet of new rock. But in their place, new vents had already begun to form, spewing their chemical-rich water and laying the groundwork for the next generation of deep-sea life to colonize. It was a dramatic, real-world demonstration of how quickly and violently our planet can reshape itself, erasing and creating entire ecosystems in the blink of a geological eye. The sheer scale of that 2015 event is just staggering to think about, a reminder of the immense forces that are constantly shaping our planet, often completely out of our sight. If you're finding this deep dive into Earth's hidden engines as fascinating as we do, please take a second to hit that like button. It's a small click for you, but it massively helps our channel bring more of these incredible natural stories to light for everyone. So, with the precedent of 2015, you might think predicting the next eruption would be straightforward. If the volcano is swelling and shaking, an eruption must be just around the corner, right? Well, this is where the story gets more complicated, and for the scientists monitoring it, more unnerving. Axial Seamount is not following the same script this time. One of the most critical warning signs is inflation, the slow, steady swelling of the volcano's surface as the magma chamber fills. Before the 2015 eruption, the volcano was inflating at a blistering pace of 2 feet per year. It was a clear, unambiguous signal. This time, however, the inflation is much slower, currently rising at a rate of about 8 inches annually. While that is still highly significant, the pattern is what's causing confusion. Professor Wilcock described the process as very erratic. He explained, "It inflated quickly, then almost completely stopped. That's what's made this eruption harder to predict. The magma appears to be rising from deep within the Earth through a more complicated, irregular, and choked pathway. This slow, stuttering ascent means the pressure is building less uniformly, making it incredibly difficult to pinpoint when the breaking point will be reached. This uncertainty has led to a wide range of predictions. On one hand, the current seismic activity and the simple fact that the volcano's surface, as noticed by geophysicist William Chadwick in November of 2024, had swelled to nearly the same height it reached just before its last eruption, means that, by all appearances, it could erupt any day now. But the erratic behavior has led researchers to believe it's statistically more likely that the main event will occur sometime by July of 2026, or perhaps even as late as May of 2027. As Professor Wilcox soberly put it, we think there will be some warning, but then again, volcanoes do tend to surprise people. The giant is awake, but its next move remains a dangerous mystery, and the mysteries don't stop there. Beyond the question of when, there is a new and alarming question of where. Traditionally, volcanic eruptions happen at the summit, the main vent where pressure finds its easiest escape route. But the scientists studying Axial Seamount have identified a potential new threat, a different kind of eruption that could be even more unpredictable. This is the frightening possibility of a dike eruption. Emilie Hooft, a geophysicist at the University of Oregon, has voiced this concern. A dike is essentially a vertical sheet of magma that, instead of rising straight up, pushes sideways through cracks in the Earth's crust. Imagine a tree root forcing its way horizontally through the soil. If this were to happen, the magma could travel for miles laterally, far from the main volcanic center that is so intensely monitored. It could then erupt somewhere completely unexpected on the seafloor, bypassing the primary network of sensors and catching scientists by surprise. This would not only complicate the study of the eruption, but also highlights how much we still have to learn about these complex underwater systems. The volcano isn't just a simple cone with a hole in the top. It's a sprawling, interconnected network of hydrothermal vents and magma pathways, some of which we may not even know exist yet. An eruption from an unknown flank would be a stark reminder that even with our most advanced technology, the Earth can still pull a fast one on us. The deep ocean holds its secrets close, and Axial Seamount may have more than one way to unleash its power. At this point, you might be thinking, this is all fascinating, but it's happening 300 miles offshore and more than 4,900 feet underwater. Why should someone in, say, Seattle care? And that is the most critical part of this entire story. While it's true that an eruption from Axial Seamount poses no direct threat of a tsunami or ash clouds to human life on the coast, its true importance lies in the knowledge it provides. It is a perfect, albeit remote, natural laboratory, and the lessons learned from forecasting its behavior are absolutely vital for predicting eruptions from nearby volcanoes that very much do pose a catastrophic risk to people. Enter Mount Rainier. Just 240 miles from Axial Seamount, this colossal ice-clad stratovolcano is not a remote geological curiosity. It is a monster that looms over the entire Pacific Northwest. Nearly 90,000 people live in its direct hazard zones, with major metropolitan areas like Seattle, Tacoma, Yakima, and Portland home to millions lying in its shadow. The primary danger from a Mount Rainier eruption isn't necessarily a classic lava flow descending the mountain. The far greater and more insidious threat comes from lahars. Mount Rainier is draped in more glacial ice than all the other Cascade volcanoes combined. When an eruption occurs, the intense heat will flash melt this ice and snow, creating a terrifying slurry of water, mud, rock, and debris. These lahars can surge down river valleys at speeds exceeding 50 miles per hour, with the consistency of wet concrete, burying everything in their path under dozens of feet of mud. They can travel for tens of miles, reaching populated areas in under an hour. This is why the early warning signs are so crucial. The knowledge of how magma moves, how the ground swells, and what seismic signals precede an eruption, lessons being learned in real time from the relative safety of Axial Seamount, are the very tools that will give authorities the precious minutes and hours needed to issue evacuation orders and save lives when Rainier decides to wake up. In essence, the rumbles of the deep-sea giant are a dress rehearsal for the day the terrestrial titan awakens. So, the axial seamount stands as a powerful duality. It is a ticking time bomb, rocked by hundreds of quakes a day, its magma chamber swelling towards an inevitable and spectacular eruption. It's a place of immense geological violence, where the ocean floor can drop by 8 feet and lava flows can build structures taller than skyscrapers. Yet, at the same time, it is one of our greatest classrooms. It's a priceless opportunity to study the inner workings of a volcano in real time, honing the skills and technology that could one day save thousands, if not millions, of lives from a future catastrophe on land. The warnings from the deep are not just for the scientists, they are for all of us, a profound reminder of the dynamic, powerful, and sometimes violent planet we call home. We are constantly monitoring developing stories like this, from the deepest oceans to the highest peaks, to bring you the full picture. To ensure you never miss our next investigation into the incredible forces shaping our world, be sure to subscribe to the channel and ring that notification bell. For now, all eyes remain on the deep, listening to the tremors and waiting for the giant beneath the waves to make its